All right, so simplifying radical expressions 11.2. We want to go over some rules of exponents, so please take a moment and orientate yourself with the rules. So here are the different rules. There are, what do I have up here? 5 rules, and these are some written examples of those rules. Basically, if you're multiplying the bases the same, we add the powers. Here you can distribute the power through. This one, when you have one base and 2 powers, you multiply them. When you're dividing and the base is the same, you subtract the powers. And in this one, if it's division, you can still distribute that power through if it's in parentheses. We're going to use these rules to simplify some rational expressions. We're going to go through and just simplify some rational expressions. We need to make sure that we are taking the time to understand our rules and use them appropriately. So the first ones we're going to do is just simplifying. We have 25 that is raised to the 3/5 power. So I want to maybe rewrite this. I think that rewriting it makes it, it shouldn't be 25 to the 3/5 powers. It's times 25, I forgot to write the rest of the problem, to the 7/5 power. Now, since the base is the same, we want to add our powers. So we keep the base, and we're going to add 3/5 plus 7/5. Now, it's fractions. They do have a common denominator. So I can change that to 25 to the 10/5. Well, 10/5 is simply 2. So that's 25 squared, which is 625. And that's simplified. It's all the way down to its smallest value. Now, on number 2, we want to distribute that power, but I want to deal with what's inside first. So I need to, because this is dividing, I need to subtract these powers. So we're going to go y to the 4/3 minus the 2/3. The 16 is going to stay put. And we have that 3/2 out there. So 4/3 minus 2/3 leaves me at y equals 2/3. And I have 16 on the bottom. And it's raised to the 3/2. Now, I'm going to distribute that 3/2 to both the numerator and denominator, because when I do, I get y to the 2/3 times 3/2 over 16 to the 3/2. Well, let's see. 2 times 3 is 6. 3 times 2 is 6. So this gives me y to the 6 over 6 on the bottom. Dealing with this, I'm going to change that to a radical real quick because I want the square root of 16 to the 3rd. Going back to my numerator here, that's just y, because 6 divided by 6 is 1. Here, what's the square root? And I can do this 2 ways. Let's do it this way. Put the 3 on the outside, because one of our rules said we could do that. Square root of 16 is 4. And then I'm going to raise it to the 3rd power, which is 64. So my final answer is y over 64. And we've simplified it down. Can't take it any further. On number 3, again, we're going to distribute this to each of these. The 27 gets the 2/3, and the x to the 3/4 gets the 2/3. So 27 to the 2/3, x to the 3/4. Since it's one base, 2 powers, we're going to multiply. This one I'm going to change. I'm going to write it as 27 and then squared. Here I'm going to multiply it out. 3 times 2 is 6. 4 times 3 is 12. This one, 27, that's 3 times 3 times 3. So the cube root, I take a group of 3's out. I square it, x to the 1/2. So I get 9 square roots of x, or you can leave it as 9x to the 1/2. Either way is the simplified version. So we're going to look now over yonder at 4 and 5, and all we've done is just kind of made things a little bigger. We have some x's and we have some y's. The key here is to be able to do these two things. These indexes have to be the same. So since they are, I can put them under one radical And I can say, okay, I'm going to multiply 2y times 4x squared y squared. And I can simplify things down. The x stays out here. I get 8x squared y to the third. Now, it is a, not square root, but a cube root. So I want to take out groups of 3. So I want to break everything down. 8 can be rewritten as 2 times 2 times 2. I have 2 x's. And I have 1, 2, 3 y's. That 3 on the y means there's 3 of them. The 2 on the x's means there's 2. And 8 breaks down to that. And it is a cube root, so I want to circle the groups of 3. Well, everything but the x's get circled, so anything circled comes out. So we have a 2. We have an x that was already there. The y comes out. And then we have a cube root of x squared. And that's our final answer for that problem. Now, on this last one, we need to do something a little bit more creative because these do not have the same index. The top one is a 2 and the bottom one is a 3, so I can't really combine them yet. So I have to get creative and rewrite them. So I'm going to rewrite this as 16y to the 1/2 power, or not 16, that's a 64. And then on the bottom, I'm going to write it as 64y to the 1/3. Now, the reason why I did this is the base is the same. So the rule says if I'm dividing, I really just subtract the powers and I keep the base. So 64y, and I say to the 1/2 minus 1/3. Well, the catch with this is they have to have common denominators because they are fractions. So 64, this is 3 6 minus 2 6, because remember, a common denominator would be 6. 3 times 2 is 6. We multiply the top by 2, or 3. And this one, since we multiply the denominator by 2, we're going to multiply the numerator. So that leaves me with 64y to the 1/6 power. And we're done. We can leave it just like that. We could break the 64 down because 64 is actually 2 times 2 times 2 times 2 times 2 times 2. And if you don't believe me, you can check. And to the 1/6 power means we want the cubed root. So we could rewrite that because all the 2's would come out. So we would get 2y to the 1/6. And that would take it a little bit further. Now, we have a couple more examples we want to look at for today. We're going to look at a few more that I'm going to write on the board over here. And these are, like I said, just a couple more that we're breaking down. So here is another example, and I will move the swivel so you can all see, because I know you are all very, very much ready for this. All right, so you should be able to see this one now. So number 6, we're going to work out. And we want to make sure that as we're working this out, we're going to simplify things down. 256 is a huge number, but the key thing here is I'm not multiplying it times anything else or doing anything like that, but I want to take out groups of 3. So I need to break down the 2. So 56, that's 2 times, let's see, 256 is 2 times 128. And the 128 is 2 times 64. And we already decided that 64 had 6 2's in it. So that's 2 times 2 times 2 times 2 times 2 times 2. That's 8 2's. 8 of them. So the cube root, that's 1, 2, 3, 4, 5, 6, 7, 8. Just to get the 256. The reason why I want to break it all the way down is we want to circle groups of 3 and pull them out. Now, I also have in here 3 groups of x and 1, 2, 3, 4, 5, 6, 7 groups of y. And I want to circle things in groups of 3. So there's 1, there's 2. I've left with the 2's. The x's all come. 1, 2. So inside I have 2 2's and a y, and I can't do anything about it, so they're going to stay in there. 2 times 2 is 4, and I have a y that's in there. And then everything on the outside is going to come out. I have a 2. My groups come out as 1. I have an x, and I have 2 groups of y. Now I'm going to squish it all back together. So that's 4xy squared cube root of 4y. Now, want to look at a little bit more. So we're going to add a couple more problems. Number 7 is the 4th root of 81 over x. Now, this means that I want to change things, and I have to also rationalize a denominator because we can't leave radicals in the denominator. So what we want to do is we want to break this down as the 4th root of 81, and this is the 4th root of x. So we can't leave radicals in the denominator, and those x's are not going to come out. But 81, I want to try to break that down. If I use a little factor tree, that's 9 times 9, so that's 3 times 3 times 3 times 3. So on my numerator, I have 1, 2, 3, 4 3's, and my denominator, I only have 1x. To rationalize this, I need to make a group of 4 down here. I can't leave a radical in the denominator. So I have 3 out of the 4 I need, so I'm going to multiply the numerator and the denominator by 3 more x's. If I put 3 more x's here, I have a group of 4. So on the numerator right now, 1, 2, 3, 4 3's, 1, 2, 3 x's, and on the denominator, I have 1, 2, 3, 4 x's. Now, I could put these under the same radical as well, but these get to come out because there's a group of 4. These do not. So I have 3 4th root of x cubed, and on the bottom, I have the x because these all get to come out. And that is what we call rationalizing as well as the simplifying. So I want to look at one more with you. I think it's just one more. I'd have to check my other side of my paper. So this is number 8, and we have the 4th root of 16 over x to the 14th. Now, 16 breaks down to 2 times 2 times 2 times 2. 16 is 4 times 4, so we have 4 2's in there. And again, I'm going to split the top to the bottom. But here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 x's. The top, great, wonderful. They come out as 1. The bottom, I got to circle them to groups of 4. Uh-oh, I got 2 left. So the 3 that come out, they're fine. I'm not worried about them. But the 2 that are left, I can't leave that radical in denominator. So I really, really need to make sure that I don't have any radicals in that denominator. So what I'm going to do is I'm missing a set of 2 to make that complete 4. So I'm going to multiply by 2 on the top and 2 on the bottom. So keeping a fraction balance means you do the same on the top as you do on the bottom. So we have 2, we have that x cubed there, because 3 times those. And then on the bottom, these are going to make 1, 2, 3, 4. And up top, I have those 2 that I added in. So that's just an x squared. These will come out. So we get 2, the 4th root of x squared. I have x to the 3rd times 1 more x. Now, these can get really kind of crazy and hairy. And I know they can be kind of confusing. But they're really not so bad. We'll play with them tomorrow, and I promise by the end of class you'll start to feel better. Remember, take good notes, and we'll talk more